So we're back and we are looking at our results from the descriptive statistics. So we've got the three means up at the top: standard error, standard deviation, because we are looking at the accuracy with standard error and the precision with the standard deviation. So having a look at these means, when we're talking about the means, this one's a 4, this one's a 9 possums. Now this one I'm going to round up to 12 because I just want it to be two significant figures, and you can't have 11.7 possums, it doesn't exist. And also when I look at my data here, it's to two significant figures. Same for my standard error and standard deviation. You can go to two significant figures. So 0.38 would be your two significant figures because we only have two significant figures over here. All right, let's go up and let's talk about it. So the one with the most variation would be non-urban. Have a look. Compared to these two, this one's a bit higher, isn't it? Same with standard error, okay? There's quite a bit of standard error, which means that overall, this has a greater uncertainty to the actual data. So this mean, we're not quite sure if that mean is accurate and precise. We are uncertain. So these are two measurements of uncertainty. We are uncertain. So how do we write about this? So you can plug that, copy and paste this into your FA2. I would actually delete a lot of the other things. Maybe you want to actually keep count because that'll come in later. You might actually want to keep that. In your actual experiment though, your counts, your number of trials are going to be the same across each one, so that's irrelevant. But let's have a look. So the mean, I'm just going to make this a bit bigger. The mean plus or minus the standard error, because standard error goes on both sides of the mean, so it could be a little bit more, a little bit less, of the brush-tailed possum abundance was recorded in urban well-lit, urban poorly lit, and non-urban areas. Okay, so I've included them all in one sentence because I know that I'm limited on my word count. So urban well-lit, urban poorly lit, urban, non-urban areas, the means were 4 plus or minus 0.38, so you do two significant figures, 9 plus or minus 0.8, and 12 plus or minus 2.58 respectively. So that means in that order. Okay. Now, as I said before, there was a higher degree of uncertainty in the data collected from the non-urban site, as the values for standard deviation and standard error were greater than the other two locations. Fair? I've already said the standard error up here, so I don't really need to give more evidence of that. Then I thought, why is that? So I use some hedging language here, which is where I sort of hedge my bets. I don't say this is definitely because. I give an educated guess. Okay, I give a scientific interpretation of this. So I say this is likely explained by the small sample size in that location. So if we come over here, we have a look at the sample size. We've got less nights that they actually went out and recorded in a non-urban area. So we have a greater room for variation, okay? If I were to survey a small sample size of year 11 students, for example, about who is the best teacher, and they all said Miss Pageant, we are uncertain if that is a good representation of all the year 11 students. It might be actually turn out to be precise and accurate and everyone loves me. However, because the sample size is so small, we are uncertain if that is the case. So that's really what it is, okay? I will now go into comparing the actual means themselves. So because we have such a large error and deviation, such a large uncertainty around this one, is it actually really that different from this one? If we minus from 12 2.5 or 2.6 roughly, we're going to get pretty close to 9. So are they actually that different? That's what a t-test is. So let's get into t-tests on the next video. Catch ya!